Okay, hope everyone are here. Okay, let's start lab 3 today, and lab 3 will be due next Monday. Okay, there is nothing due for you all today. Fine. So what is lab 3 about? Lab 3 is all about finding the slopes of a tangent line. I hope you all know what is the tangent line and how do you find the slope in your lectures, right? So how do you find in MATLAB? So for this we will have 3 different methods on finding the slopes of a tangent line. We will see how does each method do. Okay. So first method is, this is like a old one, I can see, which also takes a lot of time. So what you have to do is, you will be given a function. So you know how to define a function, right? And then you will plot a function. Okay? So you have a function cos x. You have a function cos x. I want you all to plot it out. Okay? Using isplot. So you will have only this blue one, the blue line. You can see only this blue line if you write code from 1 to 3. Got it? And now I'm going to pick up 2 points, a pair of points for x and y. Okay, how do I pick up? When you plot a function, when you plot a graph for the cos x function, you will get graph like this, the blue one. Okay? So you will not get a straight line, but when you actually zoom in at some point, when you see a tangent, or if you feel that the curve is like a straight line, then just zoom it and see whether it's a straight line or not. You will definitely find a straight line there, and at some point there or surrounding that point, find out the points nearby. You can take, instead of 1.98, you can also take 1.5 if it is very close to 2. Okay. So if you're feeling that your function is a straight line at 0.3, okay, it is not. But if you feel that it's a straight line at 0.3, take surrounding points, the points which is around 3, and the corresponding y value. I'm sure you all know how to do this because the lab 2 was about this only. Okay? And then after I pick up all the x1, y1 and x2, y2, now I'm going to find the slope of a tangent. So you know the formula, right? This is the formula for slope of the tangent. So for this you need y2, y1, x2, x1, and that is why I picked up these set of values using this graph. Now I'm going to use this command called as hold on. Why? I'm telling my MATLAB that do not plot until I say hold off, because I'm going to plot another graph, that is this, a tangent graph. So I'm going to plot the function graph and also the tangent graph in one easy plot. Okay? So that is why I said MATLAB to hold on. Got it? I don't want separate figures for the tangent and cos function. I need my cos and tangent function in one figure. So that is when you use this hold on. Okay? Now, after you know the slope value, what is y? I mean, the tangent. How do you find the tangent after knowing the slope value? This will be the formula for that. Okay? Tangent will be equal to y1 plus m into x minus x1. Okay? After that, you are going to plot a tangent for the given interval. In your question, this interval will be mentioned. If not, you can take some intervals. Okay? And then just off the hold. After that, run. Okay? Once you do that, you will definitely find this figure. So when I said I can see this, Let me run it. Okay. So you have your tangent value here. Okay. So as I told you, there is a straight line for this cost function, the blue one. Okay, do not see this red one. I'm only talking about the blue one. So when I zoom in, okay, can you see? The blue one is actually a straight line, which is also intersecting our tangent line. Okay, and now I can clearly say that at the point 2, as you can see at point 2, it is almost close to the tangent line, and also it is a straight line. It's not at all a curve at this point. So I am taking a value which is very close to my value 2. Got it? This is how you will select the values. Fine. And now going to the next method, that is finding out slope of a tangent using secant line. There is a connection between secant line and tangent line. Okay. So how do you find slope of a tangent using secant line? First is that, very simple, you're just going to replace this x1, y1, x2, y2 coordinates with c and f of c. Then c plus h, that is the next point. x1 is the first point, x2 is the second point, right? So c is the first point and the next point will be added with some number. Say my x1 is 2, x2 is 3. So what is the difference between x1 and x2? It is 1. Okay, I'm going to add 1 to x1 to get my x2 value. Likewise, when you get the point c here, the third point here, the value 3, at value 3, this point I can call it as c plus h. Because when you add some value to the c, you will get the second point. Okay, that is the meaning of that. And difference between those two values will be h. Got it? So I'm just going to replace the coordinates with the different notation. And now, going back to the code, just define the variables whichever you are using below. Now you are going to define your function and then you will find out the slope of a secant line. Okay, for that this is the formula. dq is nothing but difference quotient. Okay, difference quotient. Do not use any other variable other than this because dq is a built-in function. Got it? And then this will be the formula for that. Now secant line. You are going to find the value for a secant line and then you will plot for tangent line. Okay. So then we found the secant line equation. After that, I know from the first method, I know that my value will lie around 2. Okay. So I can take my value as 2. So, and one more thing. When do you use this my x? You use this only if you want to find a very close values to 2, or if you want to define closer values to the selected value, you use this myx command. Okay. Do not use this command inside a function. That gives a different meaning. You will get a different value when you do that. And now I'm going to select some values nearby to 2. So I'm just using a command called as small h. You can use it as small p, q, whatever it is. But make sure you use the same thing here also. Okay. After this, I'm going to use VPA to get my decimal values. And then what am I going to do is the actually relation between the secant and tangent line is when the values of secant line is 0, if you get your x2 and x1 as 0 in the secant line, that is nothing but your tangent line. So you actually want your secant line to go 0, to approach 0. Then you will get your tangent line. And that is why I use the limit function for this slope to make that as 0. Got it? So limit function h tends to 0. Got it? And now I'm going to calculate the limit of the secant line finally. So once you calculate the limit of slope, and then you have to calculate the limit of the secant line. After you do this, it's done. Got it? This will be the graph for that. So what and all you have is cos and a tangent line. Actually a tangent line using the secant line. Okay? Yes, the command which is used here is the secant line, but this is your tangent line. Why? Because the secant line is approaching to 0. So when secant line approaches to 0, you get a tangent line. That is how you find your slope of your tangent using secant line. This is one method. And the last method is that this is very short, but you will have to, this is like a trial and error method. Okay? So one more thing is, when you observe this graph, if you want your tangent line, then you must get this red line, okay? This red line close to 0. It has to approach to 0, okay? This is not at all a 0, right? So if you want your value, if you want your graph to approach to 0, then your h must be very small. Got it? When your h is very small, you will get the graph to be 0. The line. It touches the 0th line. Okay, for that, I'm going to plot my function f of x, like I did here. Okay, so I'm going to plot my function. Hold on, because I'm plotting the slope of the secant line also. So I'm plotting the slope of the secant line, and my h value, 0.5 is my h value. I'm going to give my h value as 0.5 and see whether it touches the 0th point or not. So once I do that, you can see it is not at all touching. So what I will do is, let me check whether it works for the very smaller values of h. So I'm going to give it as 0.25 and run the code. It is almost close to 0. So let me give it as 0.05. See? Right? It is approaching to 0 when your values of h is very, very small. Got it? So this is what you are likely about. So in your assignment, you will be using only this method, a systematic approach to approximating tangent line. This method is used. So most of you had asked to give hints or how to solve assignments. So let me give you hints on that. Okay. So this is your lab 3 assignment question. What you have to do is, first is that you will have to define a function and then plot it. How do you plot the function? Using easy plot, right? So first write since x and then plot, input this into MATLAB. How do you input? This is the absolute function. So how do you do that? Okay. P of x is equal to absolute, ABS is the command for absolute, x square negative 5 into x plus 6. Okay, this is how you input in your MATLAB the equation. For the interval 1, 4, how do you plot it? Use the command easyplot. What am I plotting? The function p of x, comma, the intervals. What are the intervals? 1, 4. 1 and 4. That's it. This is how you plot the function. You must know by now, we have already completed 2 labs actually. Okay. So once you do that, now you are going to find the dq. Okay. So find the slope of a tangent line. You have given certain values for x. So you will have to find the dq function. So how do you do that? Use this command, this code, copy and paste it. So here you are just going to change your function. Everything will be seen. Okay, everything will be seen. And now coming back here, your x values are given 1.5, 2.5 and 3.5. So for 1.5, copy this code, paste it, find dq at 1.5, secant line at 1.5. Okay, once you are done with that, go with 2.5. Likewise, you have to do it for the other values also. Okay, once I do that, first replace this value with 1.5. Small h will be same as it is, dpa is same, and then you are going to apply limits, right? That is what is asked. By using limits in the dq function as h goes to 0. Now find out what is the value for this. You actually no need to find this also because only dq is asked. So find out what will happen when dq approaches 0, whether you get a positive, negative or a 0 value. So, and also, you will have to mention the reason why are you getting this value. I mean, whether, if you are getting positive value, why are you getting positive values? The reason might be the h value, your h value, or it might be your function, absolute. So when you have a absolute equation, your values will definitely be positive. So I actually told you the answer. So second one is, at x is equal to 2, see what happens to the graph. Got it? For these points and for these points, write the code for this function and find out the dq. Okay? You're clear with this? So this is for the first one. What about the second one? The whole thing is for the second one. Till here is for the second part. Got it? So they are telling you that you will have to plot the graph and analyze what happens at x equal to 2. First we will do it geometrically. Plot p of x. How do you plot this? This command. Only the starting 3 lines. Plot p of x. You would have done in the first attempt. First step. Okay, plot p of x and you will have to plot secant line 2h comma x. Where do you find this? Here. Use this code. Run it with the interval 1 and 4 for small values of h. The h value is given here. Got it? Is it clear? Okay. You will have to replace your h value here. You will have to replace it as 0.001. Got it? For the first one. Plot the function. And then, likewise, replace it for h is equal to negative 0.001. And tell me what happens for the graph. Now, that is one thing. And also, you will have to find dq again at x is equal to 2 when h approaches 0. Got it? So here what you did was you did find dq using limit only for a certain values. Here you will be finding you will be determining the left and right hand limit for the dq2 comma h. So you know how to do this because we did this in the first lab. Okay, remember we did this in the first lab, left and right hand limit. And also you have to find the limit exactly at 2. Got it? As h approaches 0. So find this and answer this question. What about the third point? So there is one point on the graph where the limit of the dq function does not exist. What do you mean by does not exist? It means your value for dq should go to infinity. You will definitely get the infinite value there. You will get NaN, not a number. That error, or you can say a solution. You get the solution and you will have to mention that point on the graph. When you get that infinity, you have to mention that point on the graph. Got it? So that is for your third one. I hope this information is more than enough to complete your assignment. So if not, email me. I will definitely reply. Okay. One more thing is due dates. If you are confused about due date, go to course content, click on my name, resources, weekly schedule. Okay. You will have your due dates here and also the lab. The lab dates will be mentioned here. The due date for the lab is also mentioned. Got it? Fine. So any questions?
I don't have any starter question, but if I have one, I'll let you know. In the email?
Yes. You can email me.
Okay.